Good morning, my dear students. Welcome to online classes. So today our concept is armature windings. So here armature winding means we are already listened in our DC missions and at the same time in our electrical missions too, induction missions. So now what is the purpose of armature windings? Armature windings are nothing but the arrangement of a conductors in an armature circuit to induce EMF. To induce EMF. For the production of EMF in a generator, we can use armature windings. Armature windings are nothing but conductors. The conductors are arranged in the form of windings around the inner periphery of the armature or slots provided by the armature. Is it? Now, in order to discuss about the armature windings, first we are going to discuss about some important terms related to the armature windings. What are those means? First one is conductor. What is mean by conductor regarding to the winding terminology of electrical machines? Means here a conductor means a wire of certain length L meter is placed in the magnetic field. When a wire of certain length L meters is placed in the magnetic field, what happens? Which can induce the EMF. That's why that certain length of wire is called conductor. A length of wire which takes active part in the induced EMF is called a conductor. And one more thing is that turn. When two conductors are connected together at their ends, which can form a turn. Is that? Or otherwise, when two conductors are connected in series, which can form a turn. That's why a turn consists of two conductors connected to one end by an end connector. That means see here. This is turn, one turn, because of this is one conductor and this is another conductor. These two conductors are connected at the ends. That's why this total arrangement is called as a turn or single turn or single turn. And now see here, if you can see, this is one conductor, this is one conductor, these two are connected in series here by end connection. That's why it is one turn. And one more thing is that here it is also one conductor, this is also one conductor. These two conductors are connected this connection. That's why here these two turns are there. Is that? So that's why here, what happened here? These are the two turns right now. So anyway, turn means when two conductors are connected by its ends. That is called as a conductor. Then coil. Coil means what? When two or more conductors are connected in series, that forms a coil. Is it? So see here. A coil is formed by connecting several turns in the series as shown in figure. That means see here. This is called a single turn coil. Why? Because of only one coil. Is it? A coil means two or more turns are connected in series. Is it? So this is one turn, this is another turn. These two are connected in series like this. That means here two or more turns are connected in series means only one end of turn is connected to another end of the another turn end. Only one end of the turn is connected to the another turn end, that is called a series connection. When two turns are connected in series, that will form a coil or simply two turn coil. Is it? So it is simply single turn coil. Is it? And here if you can observe, this is one turn, this is second turn, this is third turn. When two or more turns are connected in a coil, that is called as a multi-turn coil. That is called as multi-turn coil. Is it? So that means here this is the starting end. S means the starting end. F means the finishing end. F means the finishing end of the coil. One more important thing is coil side. Coil side means the side of a coil is nothing but coils. Is it? So this is a total coil. This is called coil side. One coil side, left side of coil, and this is another coil side, right side of coil. If you can observe that, if the coil is having any number of turns, but that coil is having only 2 coil sides. Because of coil sides means the sides of a coil. That's why the coil is having any number of turns, that is having only 2 sides. Is it? So next definition is winding. What is mean by winding? So when 2 or more coils are connected together, and 2 or more coils are connected together, that arrangement is called as winding. Connected together means those coils are connected in series connection. Series connection means one end of the coil is connected to the any one end of the next coil. That is called as a series connection. When 2 or more coils are connected in series, that arrangement is called as winding. Here simply serial order. If 2 conductors are connected in series, that is called a turn. When 2 or more turns are connected in series, that is called as coil. When 2 or more coils are connected in series, that will form a winding. And such type of winding is arranged in the armature circuit. Such a winding is called as the armature winding. Is it? Next one is, this is a simple armature winding. This is one coil. This is another coil. This is another coil. Totally here 3 coils are there. Is it? This is the starting end of the coil S1. Starting end of first coil S1. This is the finishing end of first coil. When the finishing end of first coil is connected to the starting end of second coil, then these 2 coils are connected in series. And at the same time, the finishing end of second coil is connected to the starting end of third coil or fourth coil or nth coil. That is also called a series. That means here n number of coils are connected in series. That should form a winding in the armature circuit. The total winding in the armature is called armature winding. Is it? Next, single layer and double layer windings. In the armature windings, the types of windings here in the armature windings, again those are classified as single layer and double layer windings. Is it? So what is mean by single layer winding? First, single layer winding means, generally see here now, in the armature circuit, the winding provides on the slots of armature. First, armature is having slots, as already we are discussed in the silent pole type rotor and round rotor. First, armature is having slots. Is it? Rotor means that is only field winding. Is it? Armature winding is employed in stator. Is it? We are discussing the stator construction. In that stator, what happens? Slots are there. Stator, what happened? Slots are there. In that slots, the armature windings are provided. Is it? So in that slots, the coil side is accommodated on a full slot. One coil side is arranged on a complete slot of a coil, on a one complete slot of a armature. Such type of winding is called single layer winding. Means one coil side occupies total slot area in the armature of machine. Such winding is called a single layer winding. That we will see in the figure. See here, these are slots. These are slots. These are slots. In the slot, this rectangular shaded arrangement is the coil side, not coil. Not coil. This is coil side. This coil side is placed in the complete slot area. Is it? That means here number of coils in a slot is equal to S by 2, where S is the number of slots. Is it? Number of slots means what happened here? One slot is there, per slot here. And in that slot, only one coil side is arranged. That's why number of coils in a slot is equal to number of coil sides, only one, or otherwise S by 2, number of slots by 2. In case of single layer winding only. In case of single layer winding, number of coils are equal to number of slots divided by 2. Number of slot means only one slot. Why? Because of single layer winding, can be defined at a coil side occupies by total slot area. Or otherwise, if the armature winding is having 12 slots, number of coils are equal to the 12 by 2. That is number of slots by 2. Is it? That means what happened? Number of slots are 12 divided by 2, 6. That means number of coils are equal to 6 because of each slot is having only one coil side. That's why number of coils in a single layer winding is equal to number of slots divided by 2. So this type of single layer winding can be used for only smaller machines. Only smaller AC machines. Is it? What is the reason behind that? Means here, what happened here? Only single layer winding means what happened? Number of conductors are less. When number of conductors are less, means low voltage is produced. That's why which can be used in small AC machines. And a double layer winding. What is mean by double layer? Single layer winding is one coil side per one complete slot area. But double layer winding means if we can consider even number of coil sides. Even number of coil sides means either 2, 4, 6 or 8. That means 2, 4, 6 or 8 coil sides. Number of coils. 2 coil sides or 4 coil sides or 6 coil sides. Like that, even number of coil sides are located in a slot area as a double layers. Such a type of winding is called as double layer winding. See here, this is one slot. In this slot, 2 coils or 4 coils or 6 coils or 8 coils are arranged in a double layer formation. Such type of winding is called double layer winding. That's why when slot contains even number of coil sides in 2 layers in the armature of machine, such winding is called a double layer winding. It is a 2 coil sides per slot. These 2 coil sides per slot. That's why what happened here? Here 2 coil sides in a double layers. That's why it is called as double layer winding. One more thing is it is what happened? 4 coil sides are there. 1 coil side, 2 coil sides, 3 coil sides, 4 coil sides. Layers can be shown in horizontal, 2 layers. And conductors means total shaded rectangular box. Conductor means I am telling about here coil size. Coil size means total shaded rectangular box, and layers means horizontal one. Here 2 layers are there, and 4 coil sides are there. That's why here double layer winding having 4 coil sides per. Anyway, the coil sides are arranged in the form of double layers of a armature slots. Is it per slot? Such type of winding is called double layer winding, and this is called a top layer. This is called bottom layer. Is it? Now, what are the advantages of double layer winding over single layer winding? Is simply what happened. This arrangement is easier and also less cost. Because of if a single layer winding can be used, what happened? For example, the copper conductor is some 20 meters length. So that much of a conductor can be arranged in a single layer. What happened? More number of slots are required in single layer. But if that can be arranged in a double layer, number of slots are reduced. Number of slots are reduced means the circumference of armature circuit can also reduce. When circumference can be reduced means area can be reduced. That means the mission size can be decreased. At the same time, cost can also decrease. At the same time, inertia can also reduce. So that is the advantage of double layer winding. That's why it is easier to manufacture and lower cost of the coils. And one more thing is that when length is reduces means XL means 2 pi FL. Length is reduced means what happens? Where L means inductance, but which is also depends upon length of emission. Is it? So that's why here lower leakage reactance and therefore better performance of machine. Why it is lower leakage reactance means there is no gap, there is no air gap in a slot because of we are providing double layer. The area can be occupied by the winding. That's why what happens? There is no air gap. That's why leakage reactance also less. When leakage reactance less means what happen? Drops are reduced, leakage drops. Finally, strength of the machine can be increased. That means which can provide better performance. Next advantage is leakage reactance less means strength of the machine increases, the flux strength increases, and flux cutting angle of conductor armature winding increases means generated EMF also more. That's why better EMF waveform in case of generators. And one more thing is that due to double layer winding, we have to arrange, there is a possibility to arrange a fractional slot winding at the same time corded winding or corded winding, corded, C-H-O-R-D-E-D, corded winding. If single layer winding, we are unable to arrange this fractional slot winding and corded winding. What are these fractional slot winding and corded winding? So coming concept we will see. See here, pole pitch. What is meant by pole pitch? We are already discussed in this series. The distance between any two adjacent poles. Otherwise, a pole pitch is defined as the peripheral distance between identical points on two adjacent poles. Identical points means if you can consider one reference point for one pole and another pole, the distance between those two reference points or identical points is called pole pitch. Generally, this pole pitch is 180 degrees. Always 180 degrees electrical. And coil span or coil pitch. Coil span or coil pitch means the distance between two coil sides. See here. The distance between two coil sides. This is one coil side. This is another coil side. The distance between two coil sides is called coil span or coil pitch, which can be measured with what are the units for coil span means teeth or slots. Slots are electrical degrees. How to measure the coil span or coil pitch means by teeth, slots or electrical degrees. Based upon this coil span and pole pitch, we can define the corded coil and full pitched coils, short pitched coils. See here. When the coil span or coil pitch is equal to the pole pitch, then the coil is termed as full pitch coil. See here. So see here, when coil span is equal to the pole pitch means the distance between two adjacent poles. If we can consider identical points of poles, that is pole pitch. Coil span means the distance between two coil sides. When coil span is equal to the pole pitch, such a type of coil is called a full pitched coil. If the coil span, see here, this is coil span, is less than that of pole pitch. This is pole pitch, this is coil span. The coil span is less than that of pole pitch. Such type of coil is called as short pitched coil or fractional pitched coil. Short pitched coil or fractional pitched coil. Is it? So that's why in case of single layer winding, there is no possibility of a fractional pitch coil because of distance is equal. Distance is equal for each slot because of only single layer. That's why there is a possibility to allow this short pitch coil only in double layer winding. Is it? So what are the advantages of short pitch coils? We will see in the coming classes. And some definitions we will see here. Slot angle. What is meant by slot angle? It is the angular displacement between midpoints of adjacent slots. In the armature, number of slots are there. We can consider midpoint of all the slots. The distance between midpoint of adjacent slot is called a slot angle, which is represented with gamma. How to calculate this slot angle? Gamma means 180 degrees, electrical degrees. 180 degrees means it is electrical degrees divided by number of slots per pole. For example, if the mission, the armature is having 20 slots, number of poles are 4. The slot angle is 180 degrees by number of slots are 20, number of poles are 4. Is it? So that means what happened? 180 by 5 here. So that means 3.6. Slot angle is 3.6 degrees. Like that we have to calculate 180 degrees by number of slots per pole. Next definition is phase spread. Phase spread means the position of phase conductor in the armature winding, directly load is connected to the armature terminals. Armature terminals means armature having three phase for three phase missions. That's why three phase conductors are there. So in that we can consider one phase, the position of phase conductor with respect to the one pole. The angle subtended by each phase under one pole is known as phase spread, which is represented with m gamma, Next, phase belt, which is important. See here, number of slots covered by each phase under one pole. Number of slots covered by each phase under one pole. For example, the mission is having 20 number of slots and number of poles are 4. Is that right? Number of poles are 4 and number of phases are 3. So that what is the phase belt means? Number of phase belt m is equal to number of slots per pole per phase. So in my values, number of slots are 20, number of poles are 4, number of phases are 3. Is it? So then finally what happened here? 20 by 12. So that is the phase belt. Number of slots covered by each phase under one pole. Is it? One pole means, for example, one pole is having 6 slots. One pole is having 6 slots. For each phase, number of slots are 2. Number of slots are 2 because of for each phase, the slots are equally distributed. That's why number of slots are 2. And types of AC winding design. These are very much essential. This is the basic concept for electrical machines. Generally we have, for any type of electrical machine, 2 types of AC, not only AC windings, 2 types of windings are there. What are those, Mr.? Concentrated windings and distributed windings. Concentrated windings are under concentrated windings and distributed windings. What is concentrated winding? See here, simply in one step we will understand these 2 windings. For example, the machine is having 2 poles and the number of armature slots are 12 slots and number of phases are, for 3 phase machine, 3 phases. Means what happened here? Try to understand. So for 2 pole machine, number of slots are following. For one pole, 6 slots. So for 3 phases, 6 slot means for one phase only two slots. For one phase only 2 slots. In that 2 slots per phase per pole, 2 slots per pole per phase, 2 slots per pole per phase. All the coils are accommodated in only 1 slot. That 2 slots per pole per phase, all the coils are accommodated only in 1 slot. Such a type of winding is called concentrated winding. Otherwise, in this 2 slots per pole per phase, the armature windings are equally distributed in those 2 slots. Those 2 slots per pole per phase, such a type of winding is called as distributed winding. That is the basic difference between concentrated winding and distributed winding. So first we can discuss concentrated winding. So see, concentrated winding means what happened? All the armature conductors are located only 1 slot. All conductors are slots, coil size. One coil side is nothing but 1 conductor. Is it? One coil is nothing but 2 coil sides. 2 coil sides is nothing but what happened here? 2 conductors. So a concentrated winding is one which the coil sides of phase under one pole is located in 1 slot. Is it? The coil sides of one phase under one pole is located in 1 slot. Like see, this is 1 slot, this is 1 slot, this is 1 slot. But among all these slots, the total winding is provided. All coil sides are provided on only 1 slot. Such a type of winding is called concentrated winding. Is it? So in this winding, all turns are wound together in series to form multi-turn coil in a slot. Is it? All turns are connected in series. That means what happens? It can form multi-turn coil. When this concentrated winding is employed, means when number of slots on the armature is equal to number of poles of mission, when number of slots of the armature are equal to number of poles of the mission, then only we can provide concentrated winding. Otherwise, we don't provide because of remaining slots are empty. If slots are empty, means what happens? Air gap is there. Is it? Flux is wasted. Is it? So that's why we don't prefer when number of slots are not equal to number of poles. Then which type of missions the concentrated windings are used means when field winding of synchronous missions and DC missions. The field windings for salient pole synchronous missions and DC mission, and primary and secondary windings of a transformer. In these type of missions, concentrating windings are employed. And what happened here means if we are using concentrated winding for alternators, EMF is maximum more, but that is not a pure sinusoid. When there is no pure sinusoidal form, even though maximum voltage generated due to impure sinusoidal, not a proper shape of a sinusoidal, what happens? The maximum voltage again decreases due to harmonics. That's why we don't prefer this concentrating winding for armature windings because of EMF can be induced in armature winding. That's why concentrating windings never prefer for synchronous mission armature winding and DC mission armature winding. Is that right? That's the voltage not exactly sinusoidal. And distributed winding, we always said that. What happened? What happened here? Armature winding is distributed. Our conductors are placed in several slots under single pole. That means equally distributed. All slots are having armature winding. But in case of concentric winding, only one slot is having armature. But in case of distributed winding, the total armature conductors are distributed in the all slots of armature circuit like this. See, they are all slots. In all slots, winding is there. This type of winding is nothing but distributed winding. Is it? So if in this all winding turns are arranged in several full pitched or fractional pitched coils. What is full pitched coil? What is fractional pitched coils? We are discussed in the last double layer windings. Is it? And in which type of missions? Sorry, not concentrated windings, not distributed windings. In this type of mission, distributed windings are employed means simply armature windings of salient pole mission and DC missions, and also induction missions. Stator and rotor of induction missions and the armature of both synchronous and DC missions. What happens? This distributed winding is employed. These are the basic designings of windings. Is it? These are the basic designing of windings. Concentrated winding and distributed winding. Not only armature windings, but these are basic designing of windings in a mission. What are the basic designing of missions in a mission are? Basic designing of windings in a mission are concentrated winding and distributed winding. Concentrated windings are used for only field system. Is that right? Field system, field winding, and distributed winding is used for armature windings. But concentrated winding is employed for transformer windings. Right now, and distributed winding employed for starter of induction mission also. Is that right? Yes. Okay. Thank you.